Okay. All right, ladies and gentlemen, let's go ahead. And I'm going to record this in case you have to come back to it because it is due Monday and you might not look at it until over the weekend. Are you guys aware that all of the recorded videos are under the front page of your bulletin board?
Yes.
Yes, hopefully you know that. In case you, I'll tell you, in case you miss a notes, or if you're like, wow, that went fast, I don't think I absorbed that well. You can always re-watch the notes because they are on the bulletin board. The previous recorded lessons are on the bulletin board of the front page of Algebra 2. You don't have to rewatch the whole thing. Sometimes it just takes rewinding through one question to see how was it worked out, and that can give you a really good jump start to be able to start the homework. So I'm going to record this, so in case you need to rewind or revisit, it will be there. Today, I love this lesson. Today we get to look at what is an imaginary number. Oh, it's really not bad. You guys are gonna see, it's really, really not bad. I love this one.
I like real numbers.
Here's the thing. Some people, I often get the question of why are we learning these if they're imaginary? These do have a lot of real life applications. In fact, the reason you guys have cell phones that work so well, I know that cell phones, they use imaginary numbers. Really, the imaginary numbers are used to control the cell phone frequencies, which allows you to be able to communicate effectively. I don't know exactly how it works because I'm not in the cell phone company, but I've been told by other math teachers and then by a dad of a previous student who actually worked with AT&T. He said, oh yeah, we use imaginary numbers to control cell phone frequencies. So I was like, okay, it's confirmed. The reason I love imaginary numbers is I think if you can remember two things, they're actually really, really easy to work with. So I'm going to try to lead you through this in the best way that I can. I am going to ask you that you take your cell phone or anything that's distracting you at the end of the day, put it away because this is brand new. And if you could really lean in, get questions answered, and we'll move in. First thing I'd like to ask you to hopefully lead you through this well, if I ask you, what is the square root of 2 times the square root of 2? What would be the final simplified answer? Tag? 2, he's correct. If you were like, wait a minute, the square root of 2 times the square root of 2 is the square root of 4, what does that simplify to? 2, right? Okay, if I ask you, what is the final simplified answer? 2, the square root of 3 times the square root of 3. What's the final simplified answer? 3, exactly right. Okay, if I ask you, what is the final simplified answer? 2, the square root of 5 times the square root of 5. 5, wonderful. And turn to your partner and tell them, what is the final answer to the square root of 262 times the square root of 262? Ah, beautiful, I heard it. It is 262. Okay, using what you just did, what is the final simplified answer to the square root of negative 1 times the square root of negative 1? Don't do it on your calculator. Oh, guys, use the pattern. Use the pattern.
Negative 1.
Yes, thank you. It is negative 1. Now, if you were doing this separately, or if your calculator was in real number mode, it would say error, no real solution. That's because the square root of negative 1 in itself is actually equivalent to the imaginary number I. The square root of negative 1 is equivalent to the imaginary number I. Now, if you use the pattern we just did, you can see it. The square root of negative 1 times the square root of negative 1 is negative 1. Or once you see that the square root of negative 1 is I, it can help you determine that I multiplied by I is equal to, well, what is any number times itself? The number squared, right? So I squared is equal to negative 1. So those are the two things that if you can memorize this, and I don't think they're that hard to memorize, then that would be the square root of 2i times the square root of 2i, which would be 2i squared, which would be 2 times negative 1, which would be negative 2. We're going to get there. We're going to get there. We'll get there. We'll get there. Okay, guys, so here is what you need to grasp from today. The square root of negative 1 is I, and I squared equals negative 1. And you can see that right from above. I times I is I squared, which is -1. Now, how does this fit in line with what you know about real numbers? Well, all numbers are considered to be complex. And in complex numbers, you really have two main categories: real, which we've already learned. And something to be aware of is real is it's different from imaginary. Imaginary numbers look like this. They look like 2i, or I root 2, or 3i. Real numbers, you guys have already seen real numbers. They look like 2, or 1/2, or square root of 2. Brett? Yeah. In fact, within real numbers, we have other categories. Within real numbers, we have integers, which are basically any numbers that can be, oh, sorry, hold on, that's not next. What are the two main categories within real? This is final review. There's something that consists of fractions and something that consists of numbers that can't be put in fractions. Nice. Rational, which is like 1/2, and irrational, which consists of like pi. Then within rational numbers, then we have integers. Within integers, we have the category of whole numbers. God bless you. And then within the category of whole numbers, we have the most basic, which is taught on Sesame Street, natural. So basically, if you thought about your progression of learning, you start with Sesame Street, natural numbers, which consists of 1, 2, 3, 4, 5, 6, 7, and so forth. Then you go on to whole numbers, which my youngest had a really hard time with this, understanding the concept of 0. I have nothing in my hands. And yeah, it's really hard for them. Then you go on to integers, which consists of all the positive and then negative numbers. And then you start understanding like, oh, I could owe somebody something. I could have negatives. And then you go on to real numbers, or then you look at irrational numbers as well, which is like square root of 2 or pi. You move into geometry. Those are all considered under real. Now you are going to finally extend your understanding to complex numbers. Complex numbers examples look like this, where you have a real number and an imaginary number. The real number, if I gave you this example, would be 2. And the imaginary piece would be just I. So today's focus is going to be, how do we work with this new number? And you're going to find that it's very similar to what you've already been doing with real numbers, with this exception. Again, try to bring this to memory. The square root of -1 is what I is equivalent to, and I squared equals -1. Okay, so let's see, how do we simplify? Simplify the following. The square root of -49, the first thing I would do is separate and recognize that this is the square root of -1 times the square root of 49. Then I have to remember, what is the square root of -1 equivalent to? I. So I would replace it with I. And then I simplify the radical. What is the square root of 49? 7. And just so you guys know, we typically write the I at the end. So this is more commonly written as 7i. Number 2, the square root of -48. The first thing that I recognize is there's a negative under the square root here. So this is going to be equivalent to the square root of -1 times the square root of 48. And then I have to remember, what is the square root of -1 equivalent to? I, so I replace it. Now I do have to simplify the radical. You could use your perfect square method and say, what's the highest perfect square that goes into 48? Or you could factor it down. What do you guys want to do? The factoring tree or perfect squares? I'll show both ways. So the square root of 48 is the result of the square root of 16 times the square root of 3. What's the square root of 16? 4. So this is 4 times I root 3, which simplifies to 4i radical 3. That's the more common way that we write it. We just put the I second. Now, if you were a like factor person, this is back from the beginning, that would be 4 times 4 times 3. Remember, there's 2 of the same factor, so we can go ahead and take the 4 outside of the radical. Do you guys remember that? Okay, so that's kind of something we need to keep in mind. Number three, try this one on your own. I'm gonna walk around, see if you need help with it. See if you can simplify that imaginary number. Guys, here is what I saw first that I am just so happy about. I saw people know that the square root of -1 is I. Awesome. Then the square root of 32, I saw some people doing a factoring tree. 32 is 16 times 2, 16 is 4 times 4. So there are 2 of the same value, and so I saw 4 radical 2. I saw other people know that the highest perfect square that goes into 32 is 16. It's root 16 times root 2. In either fashion, your answer should be 4i radical 2. Any questions on that? Tobias?
I did 4 and 8.
Okay, okay. So then you would go down an 8, you could call that 4 and 2. And then you would see the 2 4s. But there is something I do want to remind the class of, so thank you for saying this. 4, if you went all the way or if you factored in a different route, you might have gone to 32's prime factorization, which is 2 to the 5th power, 2 times 2 times 2 times 2 times 2, which means we would have 2 groups of 2. So I would take out 1, 2, and then I would take out another 2, which provides that 4. So that's the other way that you could go about it. Awesome. But you do want to get to that answer of 4i root 2. All right, number 4. Number 4, when you see the square root of a negative, you should be thinking that's the square root of -1 times whatever this radical simplifies to. What is the square root of -1? I. What is the square root of 225? 15. Awesome. So my answer is 15i. And that's the answer. All right, moving on. After working with imaginary numbers on the front page, now we're going to look at how do you multiply imaginary numbers, which actually Jake already alluded to. And then we're looking at how do you divide imaginary numbers. Here's the thing to keep in mind. Simplify before you multiply. So I'll even kind of put that in here. Simplify before multiplying or dividing. What do I mean by simplify? As soon as you see the square root of -5, you want to simplify that to the square root of the square root of -1 times the square root of 5. Now, what is the square root of -1? I. So this is actually I root 5 multiplied by, and now I'm going to multiply it and I want to simplify this number. And yes, it is going to turn into, again, I root 5. Now I'm going to multiply this through. What is I times I? I squared. What is the square root of 25 times the square root of 25? Or sorry, I said that wrong. What's the square root of 5 times the square root of 5? Square root of 25. What's the square root of 25? 5. So this is I squared times 5. Now here is the other thing I asked you, try to commit to memory. Do you remember, and I know this is new, but what is I squared equivalent to? -1. If you didn't remember that, go back to this definition, especially before you do your homework tonight, and say those two things I know I'm going to be using all over the place. So I squared is -1. And so I'm going to replace that with -1. Then what is -1 times 5? -5. Now, why did I say simplify before you multiply? If you tried to multiply this out, -5 times -5 would create a positive 25. And then you would say the square root of 25 is 5, and you'd have the wrong answer. Because this is not a real number we're working with. This is an imaginary number we're working with. All right, number two. Number two, again, simplify before you multiply. So the square root of -8 is the result of the square root of -1 times the square root of 8. What is the square root of -1 equal to? I. And does anybody know what the square root of 8 simplifies to? Nice, it's 2 root 2. If you're using your perfect squares method, it would be square root of 4 times square root of 2. Okay, then I'm going to multiply it by, well, the square root of -13 is the square root of -1 times the square root of 13. What is the square root of -1 equal to? I. Okay, now I want to multiply this. What is I times I? I squared, awesome. And then I have times 2. And remember, you're multiplying radicals. You can multiply the numbers underneath when you're working with real numbers. So what is root 2 times root 13? Yes, root 26. I'm almost done. What is I squared equivalent to? -1, awesome. So I'd have -1 times 2 root 26. What is -1 times 2? -2. So our answer is -2 root 26.
What? No.
No, what happened? Oh, the next one, number 3. Okay, so again, simplify before you multiply or divide. So let's think about simplifying. As soon as you see the square root of a negative, you want to think to yourself, that is the square root of -1 times the square root of 40. In the similar fashion, the square root of -2 is the square root of -1 times the square root of 2. What is the square root of -1? I, so I can write this as I root 40 over I root 2. Now here's the nice thing about working with real numbers or imaginary numbers. Any number divided by itself, including any imaginary number divided by itself, is going to equal 1. So any number divided by itself is 1. The i's end up canceling out here. Now I'm going to take you back to what you know about dividing radicals. If you have one radical over another radical, you can combine it into one giant radical. To me, that's easier. What is 40 divided by 2? 20. And now I just have to simplify the square root of 20. You can use your perfect squares method, or you can use your factoring method. Because I've been using perfect squares, I'll go ahead and remind you of factoring. What do I know goes into 20? 10 and 2. What goes into 10? 5 and 2. And if I bring that down, I have 2 times 5 times 2. What's the number that I can take to the outside? 2. Good. So my answer would be 2 root 5. All right. Because imaginary numbers are new, you need to know now, how do we write these imaginary numbers in the proper form, essentially standard form. When complex numbers have both a real and an imaginary part, to express the answer in simplest or standard form, we need to make sure 2 things are true. Number 1, the highest power on I has to be 1, which means, I'm going to do a little thought bubble. If you see I squared, what do you have to replace it with? Close. -1. I squared is equal to -1. So if you see an I squared, you can't leave it as I squared. You always have to replace it. The other piece to be aware of is an answer is in standard form if the real part is first and the imaginary part is second. This is an example of a complex number that's in standard form. 2 plus 6i. The 2 is the part that hopefully you're more familiar with. 2 is a real number. 6i is the new piece, that's imaginary. Together, they make up the complex number 2 plus 6i. Okay, those are the 2 pieces that you really need to know. And now, when we are adding, subtracting, multiplying, or dividing, the piece that you really need to keep in mind is treat I as you would any other variable. So number 1, I'm taking 3 minus 4i and I'm subtracting negative 2 plus 6i. What do I have to do with this subtraction? Yes, distribute it in. What's in front of these parentheses? Can I take them away?
No, because there's nothing in front of
There's nothing in front, so could I put a 1 here? Would that be okay?
Yeah.
And if I distribute the 1, would I just get back 3 minus 4i?
Yeah.
Yeah, so we could do that. Now, if we distribute the negative 1, what's negative 1 times negative 2?
2
2, good, and negative 1 times 6i?
minus 6i.
Nice. Now, if I'm putting this in standard form, I have to put the real part first. So what is 3 plus 2? 5. And what's negative 4i plus negative 6i? Perfect, negative 10i. Just treat it like a variable. Negative 4x plus negative 6x would give me negative 10x. And that's my answer. Number 2, if you could turn to your partner and the person with the darker colored shirt on in the group, if you could say what you would do first.
Which is third,
You have to share what you would do here.
Wait, so it's just kind of like you can normally.
It's not bad, right? Not bad.
But I just like.
It's the square root of negative 1, and I squared equals negative 1. And if you can remember that, you're good to go.
And is that what alpha is? Like on our calculators? Is that what alpha is?
No. Alpha just is a function that allows you to access other things.
Like what is A, B, C, D, E, F?
Those are just letters. You can store different values for different variables.
Oh.
So,
Cool.
yeah. All right, guys, we should get 15 minus 7i. Give me a thumb up as I'm getting it so far, side as I'm kind of getting it down is like, I have no idea what's going on. I'm seeing thumbs up. All right, let's keep going. Yes, question.
So when we're multiplying these, we don't think that I is negative 1 and the column 4 we were making.
If there's an I squared, so the reason that, oh, yes, or if you see the square root of a negative, that is I underneath. So the reason we're not making the square root of negative 1 here is because we've already simplified. I is already there. Versus a question like this, the one before it, I was not shown, so I have to show that it is actually an imaginary number. Cody.
Is this unit 4?
Yes. Okay, guys, when multiplying complex numbers, and this is supposed to be number 1, I'm sorry, that's not actually part of the problem. You're still going to use the process of FOIL. So let's go ahead and let's just walk through that. The F in FOIL stands for multiplying first times first. So 5 times 7 would give me 35. The O in FOIL stands for multiply the outside ones. So what's 5 times negative 2i? Perfect. The I in FOIL represents multiply the inner ones. So what's negative 4i times 7?
Negative 48.
Good, negative 28i. And then this might be the trickiest, so I'm going to show it in red. A negative times a negative is a positive. So negative 4 times negative 2 is positive 8. And then I times I is going to be I squared.
Wait, does that mean it's negative 1?
Yes, and Cody remembered what we have to keep in mind. This I squared is equivalent to negative 1. So that means that this is actually going to turn into 8 times negative 1. Sadness, I was doing so good for so long. Okay, so now I have 35. What'd you say?
That was happening Miss Johnson.
I don't know what's going on. I don't know what's going on.
It's contagious.
It's contagious. Huh. Okay, so if I have negative 10i plus negative 28i, what does that combine to be?
Negative 40, 38.
Negative.
Good, negative 38i. And I'm almost done, but what are the pieces I can combine now? Yes, negative 8 and 35. So if I'm putting this in standard form, I want to put that real part first. So 35 minus 8 would give me 27. And then I have minus 38i. And that would be the answer. Cody. We're out. Yes, you can. Okay. All right, number 2, guys, do not make the most common algebra 2 mistake. Do not distribute that square. Why can I not distribute the square? What are these? Yes, we have to FOIL. Well done, Jake. This is actually 4 plus 3i times itself. You cannot distribute to terms. Don't do it. I'm going to write it again. Cannot distribute to terms. Remember, terms have pluses and minuses. If this was 4 times 3i, then you could distribute. But let's go ahead. Actually, if you could try this one on your own, if you get stuck, look up here. Well done. Was that, did you just look it up? Yes. I don't know. I'm always cold, so I don't know. All right, guys, did we get 7 plus 24i? Did we remember that I squared equals -1?
Yes.
Well done. Okay, last thing we're going to look at is dividing complex numbers. Last piece. If we have I in the denominator, remember, I is the square root of -1. You guys hopefully remember from the prerequisite chapter, we can't leave square roots in the denominator. So if we have I in the denominator, we need to use what we know about rationalizing the denominator to simplify. Here's an old example. If you had 3 over root 2, how would you rationalize the denominator? Nice, multiply it by root 2 over root 2, right? Which would create 3 root 2 over, what's root 2 times root 2? 2. We saw that from the beginning of the notes. A radical times a radical gives you the number under the radical. Okay, so now let's extend that to working with I. It says, evaluate the quotient and write your answer in standard form, a plus bi. Remember, I is equivalent to the square root of -1, which means I can't leave a square root in the denominator. What did I do in the previous example? I multiplied it by the radical to get rid of it. So what do you think I'm going to multiply this fraction by to get rid of? Square root of -1. What is the square root of -1? I. So we can just multiply by I over I. And that will become 2i over I squared. What is I squared? -1. So just quick reminder, that's the piece that we do need to know today. I squared equals -1. So this actually becomes 2i over -1. And then, are you guys aware that we don't like to keep negatives in the denominator? Do you know how to get rid of them? You can just bring it on top, like Caitlin said, or you could multiply by -1 over -1. Do you guys remember that? So then that would create a -2i over 1, which means this will just become -2i. Or like Caitlin said, you can just divide it into every piece in the numerator. Divide -1 into 2i and you'll get -2i. All right, letter B. What do you think we should multiply this by to get rid of that I? I. Multiply it by I over I. Now I do have to keep in mind what I know about order of operations, or I don't know, simplifying. 2 plus I represents one value. So what do I have to do with the numerator I? Starts with a D, ends with a distribute. Distribute, good.
Ends with distribute.
So we have 2I plus, what's I times I?
I squared.
I squared over I times I is I squared. And now the all-time favorite thing, what is I squared equal to?
What do you mean?
-1.
-1, so let's replace it. This is 2I,
Yeah, you can just cancel it out though, right?
careful, over -1. Now, we cannot cancel terms. These are terms because this is a plus sign.
Oh.
Remember, if they're plus signs, you can't just reduce them. Don't do it on the test tomorrow or Friday. You can't reduce, I can't reduce these things because these are terms. This -1 is a term because it has a plus sign, the -1 in the top. So what do I do instead?
Divide it.
Divide it, and you can divide it into both pieces. I can divide it into this, and I can divide it into this. Because this is a fraction, this is equivalent to 2I over -1 plus -1 over -1. You could do it like that, or you could multiply both sides by -1 over -1. So this is going to become -2I plus, what's a -1 divided by -1?
1.
1. And how do I write that in standard form? Which piece should I write first?
1 minus 2
Yes, well done. 1 minus 2I.
equals,
That's it. That's the answer.
what is it equal to though?
1 minus 2I. That's what it said, evaluate the quotient and write your answer in standard form, so we did it.
Okay, so it's not like, it's just an expression. right?
It's just an expression. It's not an equation. Good. Okay, letter C. What do you think we should multiply this by to get rid of the radical in the denominator?
Wait, that's 3. Oh,
You could say, I heard some people say 2I. You could say 2I, but you'll have to reduce in the end. We just have to get rid of the radical. So you could just multiply by I. Then I would distribute this through.
wait, so I is just.
It's just the square root of -1. So then that would give me 3I minus I squared over 2 times I squared. And then you do have to keep in mind, what is I squared equal to? -1. So this is 3I minus -1 over 2 times -1. Yes, which becomes 3I plus 1 over -2. And now how do I write this in standard form? What do I do with the -2? Bring it up to this one and this one. So this is going to be -3/2 I minus 1/2. And then how do I write that in standard form? Which piece should I put first? Good, -1/2. Okay, guys, there's a worksheet. When is it due for this lesson?
On Monday.
Monday. What's due Friday?
The
Practice test. If you have any homework to show me, please do it now so I don't send you an unnecessary email reminding you that Friday is the last day to turn it in for credit. Have a good day.
I won't be here on Thursday or Friday.
You emailed me, didn't you?
Yeah.
I'm sorry, I didn't even know what I was
That's fine.
doing yet, so I couldn't respond.
I